Hey everyone, welcome to 197 Concepts. In the last video, you have Hey everyone, welcome to 197 Concepts. In the last video, we have discussed the program that is written for the function of blinking an LED using the Arduino board. And in this video, I will be showing you how to execute that virtually in the Proteus software. So just quick recall. In the last video, I have told you the program itself. So a quick setup guide, what or setup information that I'm going to give here is this is, let us assume that this is our Arduino board and there are some lines. Okay, so I need two lines. I'm drawing that largely. So this is pin number 13. Let us assume 12, and yeah, this should be the pin number 11. This should be the pin number 10. So I'm going to extend these two lines. Okay, so these two, the pin number 13 and pin number 11, are going to be used for the blinking function of LED. Okay, so I'm going to connect an LED here with ground and an LED here with the ground. Okay, that's it. And see, this is just a pictorial representation that we have used two pins in the same program, in the same diagram. But actually, you need two different programs. So this is the Arduino board. This is the pin number 13. This is an LED, and this is the connection. Okay. Then you need another Arduino board, pin number 11. The setup is same, the pins will differ. Okay, so this is the basic setup, and you are familiar with the program. What we are doing is, under the setup lines, under the setup function, what we are doing is we are just defining the type of pin. So pin mode of, if it is LED built-in LED, or it is a user defined pin, LED comma output. Okay, and after coming into the loop, that's it for setup. When you come for the loop, you are going to use the command digital write. I've missed an digital light, LED comma high. Okay, yeah, it's not going there. Then a delay in order to keep an LED on for some time. Then again digital write, and LED comma low. Then again delay in order to keep it off for some time. So that was our program. Now we have created the hexadecimal files also. What we are going to do in this video is, I'm going to directly execute the circuit. Okay, for that, of course, we have to go for Proteus. So I'm searching Proteus in my laptop, and yeah, it's opening up. Here, click on new project. Browse this path is your user defined path. You can store it anyway. That's basically where you want your circuit to be saved. Okay, so if you remember, we have already created a folder named as LED blinking on the desktop, and that too you are having two different user defined. And here I'm going to save it here because I'm going to show you both in the one in just one file. So I'm just going to select this folder, and the project name I'm going to keep is LED blink. Okay, next, I'm not going to change anything. I'm just clicking on next. So this is just your what kind of layout you want to display. Okay, so this is nothing. Just I'm going to click on next, 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 finish. So you might be familiar with the Proteus. It is used for 3D designing also, for printed circuit boards. For that, all things, those were the options. Okay, so like you want a firmware program, yeah, this can, you can also type a program here also, but it's a little bit complicated, not as simple as Arduino IDE or any other software. For example, if you are using for microprocessors and microcontrollers, their DOS box will be much better for you rather than typing the program here in itself. Okay, so that was the thing. Those are the options. I'm not going to change those options. I'm just going to keep those default. And when I come here after completely clicking on next and finish, I'm going to get a display like this. So this blue line is going to represent your canvas, or you can say, you can assume this as your physical printed circuit board. And out of this line, of course, you can design here since it is a virtual thing. But in the real world scenario, if you're doing it physically, you think that this blue line is going to be your uh, complete printed circuit board. On that, you have to connect multiple things. So that's the main thing this Proteus is used for. And if you get like this lines, just toggle on the grid. Okay. Now, if you remember, we are here for making an LED to blink for a specific period of time. For that, of course, we need LED, and since we are doing user defined function and default function, definitely we need two LEDs for two different pins. Okay, and definitely we need two different Arduino boards. Okay, now the main thing here is you have to dump the library files into the main files of Proteus software in order to get your Arduino board here. Okay, so by default, they won't be able to display that Arduino board here. You have to download those, and then you have to move it in a specific folder so that you will be able to get your Arduino board here. Okay, so by default, when you are going for selecting any object, any electronic object here, let us say resistor or an LED that is already available from the software, you are going for here P button. Okay, that is known for pick devices. Just click on it, you will get here the options. So now we need LED. Just type LED and you will get all the type of LEDs that are available within the software. These all LEDs I got from the software itself. Okay, now so for better reference, for better display, I'm going to use white and yellow. Okay, so these are all different type of LEDs. So green, blue, orange, this is the bar graph, this is bicolor. Okay, so these bicolors, these are going to display two different colors. So this is the bar graph, this is an aqua LED, this is just a generic symbol, this is just a generic symbol. Okay, so that's it. I will be needing two LEDs. Okay, yeah, now I have got here excess LED. I want to delete it. Just go there, right click on it, and then click on delete. Okay, remove device. That's it. So I'm here. I'm getting two devices. So in order to place this device, LED white and LED yellow, click on the device you want to play. You want to place it on this canvas. The device will be displayed here. Go onto your canvas. Be mindful that it should be representing a pencil. If you go here, you're having different modes here. Okay, if you go for selection mode, you will get a cursor. Okay, you won't be able to place the components. You will be able to select the components. That's it. If you want to place the components, you have to go in this component mode from this tab, and only then you will get a pencil. And using this pencil itself, you will be able to draw the lines. So those lines are considered as white connections between the components. Okay, now I need to place this component. Just give a left click. So it will be highlighted in pink in color, and select your desired position and then give it a left click. Your component is placed. For zooming in and zooming out, just use your mouse scroll wheel. Okay, or else you can use here the zoom in and zoom out options also. So I placed an LED white, and now I need to place the yellow LED. I'm just going here in my devices pane, and then I'm going to click on LED yellow. Then I'm again coming back to the canvas. See here outside this blue line also I can place the component. Okay, outside the blue line also I can place the component, but it's a better practice to place in this blue line only. It's a better practice, not compulsory. Okay, now by mistake I have placed my LED here. I just need to move this into this blue box. Okay, now I will go to this component. I will select it with the left click, and then I will go for the right click, which will give me a menu. Here we will be seeing the first option, drag object, and again it will be selected in purple color. Now you can move it to your desired location. Okay, I have placed it. Yeah, for placing the component, just make a left click. Okay, now two LEDs are placed. I need two Arduino boards. Again, go for pick devices button, and at the keywords search for Arduino. Okay, so there are multiple Arduino boards. So these ports won't be available by default. This Pro, Nano, Mini, Mega, and another Mega. So you have to dump these into the software files of Proteus. Okay, now. So for now, I'm going to use Arduino 2.0. Sorry, Arduino Uno. That's version 2.0. Okay. So I'm selecting it. One Arduino board selection is one time is enough because I can place it two times. Now I've selected Arduino Uno. Come to the canvas, give a left click, and then click. Okay. So again, make a left click and click. Now you need a ground connection in order to complete the circuit. So for that, what you can do is you can take this and go for the ground pin here, which is not available here. So that's the difference between virtual thing and a real thing. When you go for the real experimental setup, you will be having all the pins. But when you come for virtual setup, the power pins and ground pins will be hidden, as you don't need in the virtual setup. Those will be internally connected to ground and power supply. So in order to get a virtual ground here, what we are going to do is you're going for terminals mode here at this left side. You're going for terminals mode. There you can see default input output power. Okay, power is 12 volts of power. We don't need that one. We need ground. I'm selecting the ground, and with the help of left click, I'm placing those here. That one and this one. Of course, you can use a single ground also. There's no compulsory that for every component you need a grounding connection. Okay, now connecting the wires. Just hover your mouse at one terminal, you will get a red square. Okay, give a left click and then drag it out. You will see a green color line. So that green color line is your wire. You just go for other terminal where you want to connect it and give a left click. Okay, so that's simple. Your wire is connected. If you have made a wrong connection, like for this should go into the pin number 13, but you have made it for pin number 7, just right click on the line. It will be highlighted in red in color, and then a menu will appear. Just click on delete wire. Okay, so from 13 to D1 and pin number 11 to anode, cathode should be connected to ground. Okay, so now this is a very clear representation of Arduino. Yes, of course, the reset pin, 5 volts pin, ground pins, and power supply pins, those are not represented here, but you can see the pins from 0 to 13, all these are digital pins. That's why this one is highlighted separately. And these are analog pins, ADC, analog to digital converter, ADC, A0, A1. These are represented differently, and these are represented just from the number 0 to 13. These are represented at A0 to A5. Okay, so only 6 pins are analog pins, and these will be used for accepting or sending analog data. Now, this doesn't mean that you should connect only analog sensors or analog actuators at the A0 and A5 pins. You can connect the mm, digital components also. Okay, digital components also can be connected at these pins A0 to A5. That's up to your wish. The only thing is these A0 to A5 pins will be having internal analog to digital converters that converts the analog signals into digital signals before coming to this CPU. Okay, now this is the microcontroller. This is just a board. Yeah, if you are using the pins A0 to A5, its representation or its identification or its global declaration will be different into the program. So there is one program where we'll be using analog to digital pins, analog pins. So we will see it in the next videos. There are some cases where we are going to use this also. Okay, now up to now, if it is just the simple representation, we are going to use only single pins. Okay, now what I'm going to do is I have typed the program, I have made the circuit. Okay, now when I try to make it run, I get a fatal simulation error. When you click on S, definitely program property not defined. Okay, that is because you have made the connections, but you have not tell the Arduino board what it should do. Okay, this means that we are having a food ready to eat, but we don't know how to eat it. Okay, so that bridge will be completed with the program, Arduino program that we have typed here. Okay, and we have typed it. We have not just typed it here, we have also created an hexadecimal file and stored it into our desired location. That hexadecimal file has to be dumped into these Arduino boards in order to make them run. Okay, now how we can dump those programs here? Just double click on the Arduino board. Okay, you will get a multiple, you can edit its properties. Okay, now there you will get one tab called as upload hex file. Okay, now so here you have to click the browse button and go for your where you have stored the hexadecimal file. So luckily I have saved the circuit in the same folder. That's why it has opened the directly. Okay, now so I'm going for default, build, Arduino, AVR, and hex file, open. Okay, okay, that's it. Now if you run this, this will run, but this will not run. That's why you're getting a fatal simulation error, because see, AVR program property not defined. That's because we have done the program in this part. We have done this program, but we have not done the program here. For your reference, let me delete this and then I will run. See, it's running. So it's on, it's off. Okay, the LED is off. Again, it is going to turn on. Again, it is going to turn off. Okay, so I will tell you how you have to calculate that 1 second. How you have to see it 1 second just after completing this. Okay, now I have to dump here the user defined pin. Okay, now so double click on this one, upload hex file, browse, and then user defined, build, Arduino, user defined. Okay, okay. Now you will get a timer here. When you start the simulation, how long the simulation has run, you will get a timer here. When you click on this, see here, animating, right? When this comes for 1.0, your LEDs will turn off. Observe here. So that has completed 1 second. The LEDs have turned off. This one has turned off. This has not turned off. There might be a difference in the program. We will check it once. So after 2 seconds, this is turned on, this is turned off. Okay. So we might have misplaced the program here, something. Yeah. In the previous program, I had 2 lines of delay. It was like this. Okay. I've changed the code, but I have not generated the hexadecimal file. So it is just operating on the previous old hexadecimal file. Okay. So for that, I'm going to stop it again. I'm going to here at my user defined one, sketch, export compiled binary. That's it. Okay, so it not might, it will have been overwritten here. It will be overwritten into the same file. I'm just going to minimize it, and then directly I'm going to run it. No need to dump again. Okay, now observe, both the LEDs are going to turn off after the completion of 1 second. So initially those are turned on. As 1 second is going to complete, definitely these are going to turn off. See, okay, and after 1 second again these are going to turn on. 1.92, yeah, both are turned on. Now you might ask, what happens if you interchange the programs? Okay, now so if you change the if you change the programs, definitely this is going to work for pin number 11. This pin number 11 is going to be operated, but as we have connected the LED to pin number 13, you won't be able to see the output. Okay, for your reference, what I'm going to do is I'm just going to open this one. I'm going to change this default into the user defined. So user defined, I have done that same program. Now I'm going to run it. Okay. Yeah, if you see here, this one is turning on and turning off. But here also the 11th pin is turning on and turning off. It is activated. It is working. But you have not connected the LED to that particular pin. You have connected it to the 13th pin. Okay. So it's a built-in LED built-in pin. Okay. That's why you won't be able to see the output. So I think you might be clear on how to execute a program for a simple program for LED blinking. And in the further videos, we will be having some complex programs where you will be monitoring the water level and all. So that's it for this video. See you in the next video.